Hi. My name is Julius Amazoon, and today we are going to learn about land use, natural resources and energy. Land is a naturally occurring finite resource. It provides the base for survival of living beings. It holds everything that constitutes terrestrial ecosystems. Increased demand on land in modern times due to the rise in human population and resultant activities has resulted in degradation of land quality and quantity, decline in crop production, and competition for land. Land and land resources refer to a delineable area of the Earth's terrestrial surface, encompassing all attributes of the biosphere immediately above or below this surface, including those of the near-surface climate, the soil and terrain forms, the surface hydrology, including shallow lakes, rivers, marshes and swamps, the near-surface sedimentary layers and associated groundwater and geohydrological reserve, the plant and animal populations, the human settlement pattern and physical results of past and present human activity, terracing, water storage or drainage structures, roads, buildings, etc. Forest resources. Forests are the dominant terrestrial ecosystem of Earth, and are distributed across the globe. Forests account for 75% of the gross primary productivity of the Earth's biosphere, and contains 80% of the Earth's plant biomass. A forest constitutes many components that can be broadly divided into two categories that are biotic, living, and abiotic, non-living, components. Forest is made up of many layers such as forest floor, understory, canopy, and emergent layer. Forests can be classified in various ways such as boreal, temperate, tropical types with their numerous subtypes. Due to increasing population and consequential expansion of modern civilization, there has been continuous depletion of natural forests over the centuries. In 1990, the world had 4,128 million ha of forest. By 2015 this area had decreased to 3,999 million ha. This is a change from 31.6% of global land area in 1990 to 30.6% in 2015. Average per capita forest area declined from 0.8 hectares to 0.6 hectares per person from 1990 to 2015. Over the past 25 years, global carbon stocks and forest biomass have decreased by almost 11 gigaton, gt. This reduction has been mainly driven by conversion to other land uses and to a lesser extent by forest degradation. Usefulness of forest resources. Forest is an important natural resource. Forests are vital for the ecological balance and play an important role in temperature regulation in the atmosphere. Forests are natural and vast reservoir of food and shelter for animals. They provide natural habitats for numerous species of plants, animals and microorganisms. Forests provide timber, bamboo, canes, leaves, grass, oil, resins, gums, shellac, tanning materials, dyes, hides, fur, fruits, nuts, roots, tubers and other useful things for human beings. Forests provide raw materials for forest-based industries. Forests are the natural home to medicinal herbs and plants. Forest directly or indirectly affects the climate, temperature, precipitation, moisture, underground water table. Forests prevent floods and soil erosion, land degradation and improve the quality of air and water. Forests help in purifying air, water, and soil pollution. Resources obtained from nature, example, from the earth are called natural resources. These resources occur naturally, and humans cannot make them. The raw materials used in artificial or man-made resources are natural resources. Classification of natural resources. Classification of natural resources can be done in several ways based on their origin, level of development and uses, stock or deposits, and their distribution. On the basis of their origin, natural resources can be classified into living or biotic and non-living or abiotic resources. Living or biotic resources. If natural resources come from living things or organic materials, they are termed as living or biotic resources. Biotic resources include plants, animals and fossil fuels. Fossil fuels such as coal, oil and natural gas are classified as biotic resources as they are formed from the decay of organic matter over millions of years. Non-living or abiotic resources. On the other hand, if the resources are derived from non-living or inorganic materials, they are termed as abiotic resources. For instance, air, sunlight, and water are abiotic natural resources. Minerals are also considered abiotic. On the basis of deposit or stock, natural resources can be classified as renewable and non-renewable. Renewable natural resources. Resources that can be used without any risk of it ending up are called renewable resources. They exist in unlimited quantity. Sun, water, wind, biomass, tides, geothermal energy, etc. are renewable resources. These are infinite sources of energy. Non-renewable natural resources. Those natural resources, on the other hand, that cannot be replenished after their depletion is called non-renewable resources. Most fossil fuels, such as coal, petroleum and natural gas are considered non-renewable resources. Non-renewable resources take billions of years for their formation, hence, their cautious and economic use is the only option left for mankind. On the basis of development of resources, natural resources can be classified as actual and potential resources. Actual resources. An actual resource is one which is used in current times. We know their approximate quantity, for example, coal deposit. Potential resources. A potential resource is one whose utility is not known at present or is not used despite having the same. Instead, it may be useful at some time in future. In other words, such resources have the potential to have utility, although it does not have any today. For example, uranium deposit in Ladakh in India. Energy is defined by physicists as the capacity to do work. Energy is found on our planet in a variety of forms, some of which are immediately useful to do work, while others require a process of transformation. The sun is the primary energy source in our lives. Besides water, fossil fuels such as coal, petroleum products, water, nuclear power plants are sources of energy. Growing energy needs. Energy has always been closely linked to man's economic growth and development. Present strategies for development that have focused on rapid economic growth have used energy utilization as an index of economic development. This index, however, does not take into account the long-term ill effects on society of excessive energy utilization. For almost 200 years, coal was the primary energy source fueling the Industrial Revolution in the 19th century. At the close of the 20th century, oil accounted for 39% of the world's commercial energy consumption, followed by coal, 24%, and natural gas, 24%, while nuclear, 7%, and hydro, renewable, 6%, accounted for the rest. Industrialization, urbanization, and unbelievable rise in human settlements have multiplied the energy requirement by several times. Modern lifestyle and man's growing dependence on machines and equipment for his personal and professional work has added to the energy demand. Global oil demand continues to grow until 2040, mostly because of the lack of easy alternatives to oil and road freight, aviation and petrochemicals, according to IEA 2016, published by International Energy Agency. Renewable energy resources. Renewable energy systems use resources that are constantly replaced and are usually less polluting. Examples include hydropower, solar, wind, and geothermal energy from the heat inside the earth. We also get renewable energy from burning trees and even garbage as fuel and processing other plants into biofuels. Wind energy. The moving air or wind has huge amounts of kinetic energy, and it can be transferred into electrical energy using wind turbines. The wind moves the blades, which spins a shaft, which is further connected to a generator, which generates electricity. An average wind speed of 14 miles per hour is needed to convert wind energy into electricity. Wind-generated electricity met nearly 4% of global electricity demand in 2015, with nearly 63 gigawatts of new wind power capacity installed. Solar energy. Solar energy is the light and heat procured from the sun. It is harnessed using an ever-evolving technologies. In 2014, global solar generation was 186 terawatt-hours, slightly less than 1% of the world's total grid electricity. Italy has the largest proportion of solar electricity in the world. In the opinion of International Energy Agency, the development of affordable, inexhaustible, and clean solar energy technologies will have longer-term benefits. Biomass energy. When a log is burned, we are using biomass energy. As plants and trees depend on sunlight to grow, biomass energy is a form of stored solar energy. Although wood is the largest source of biomass energy, agricultural waste, sugarcane wastes, and other farm byproducts are also used to produce energy. Hydropower. Energy produced from water is called hydropower. Hydroelectric power stations, both big and small, are set up to produce electricity in many parts of the world. Hydropower is produced in 150 countries, with the Asia-Pacific region generating 32% of global hydropower in 2010. In 2015, hydropower generated 16.6% of the world's total electricity and 70% of all renewable electricity. Tidal and wave power. The Earth's surface is 70% water. By warming the water, the sun creates ocean currents and the wind that produces waves. It is estimated that the solar energy absorbed by the tropical oceans in a week could equal the entire oil reserves of the world, 1 trillion barrels of oil. Geothermal energy. It is the energy stored within the earth, geo for earth and thermal for heat. Geothermal energy starts with hot, molten rock, called magma, deep inside the earth, which surfaces at some parts of the earth's crust. The heat rising from the magma warms the underground pools of water known as geothermal reservoirs. If there is an opening, hot underground water comes to the surface and forms hot springs, or it may boil to form geysers. With modern technology, wells are drilled deep down the surface of the earth to tap into geothermal reservoirs. This is called direct use of geothermal energy, and it provides a steady stream of hot water that is pumped to the earth's surface.